Hey everybody, welcome to yet another video on titrations. This is the last one. Okay. So if you already finished the, where is it? Here we go, the titration homework, and you feel you're pretty good at it, you don't have to really watch this. This is just an assistance video, pretty much a help video for going through a titration. I'm going to do an example with you, not from the homework technically, but from another document. If you already did finish the homework, again, you can look at further down on Haiku. There is a titration lab practical, which we're going to focus on today. And also there is an acid-base discussion section or a discussion post quiz that you will need to fill out and just post on Haiku. Okay, so that's what's going on today for day 3. So for today, if you want to check out this titration example assignment right here, it's not an assignment per se, it's just an example. It's right up here. So if you want to either write it down, you can. If you want to just open the document, you can. Take a minute and write it down. I'm just going to go through how to work through a titration, and that is it. Now, if you checked out, again, or not if, but when you checked out the intro titration document here, I know it's a lot of words, there's a lot of writing on here, but it just goes through the process. So hopefully it just didn't like skip all the words, the pictures, just went down to like number 4 and 5 and finished it and said, okay, I'm done, move on to the next thing. Because I took a long time for me to type all this out and to write all this out so that you can understand the process, what goes on when you titrate something. So everything is important here. So like the color changes, when something gets neutralized. I'm seeing if you already did the homework, a lot of people for 1C are writing that the phenol that the HCl will turn pink when the indicator's added. No, it says here that phenolphthalein is clear in acids and pink in bases. So it's clearly labeled right there. And then it says what should happen to the color of the HCl with the addition of the indicator. Well, HCl is an acid. Phenolphthalein is clear in acids. That's why this one needs to remain clear. It can't turn pink right away when you add the indicator. Then that defeats the purpose of the titration. So the titration means that when you finish adding all the required amount of base, it'll turn a slight pink when it's done, not right away. That, again, defeats the purpose. Okay. So again, just make sure you're reading these things, okay? All the H substances are the acids, the bases are the OH minus substances of the hydroxides. So we're going to look at this example. Now, all titration problems are extremely similar. So you might get annoyed by how many questions there are here, but I wrote it like this for a reason. So we're going through the process step by step. And eventually on the homework, you'll get to the last few questions where it's just straight up, hey, here's the information, what's the concentration of the acid? But you still need to go through this process of writing the balanced equation, figuring out your mole ratio, finding out how much base was added if you need to, and then finding out your moles of base and acid and then concentration of the acid. All right, so it's a pretty long process, but this is why, I wish we were obviously in class for this, but, this is what it is. So titrations are a combination of stoichiometry and solutions. Combo of both. This is kind of why titrations are done towards the end of chemistry, because it's everything kind of mushed together. So for this example, we have a solution of oxalic acid with an unknown concentration. To figure out the concentration, you choose to titrate it with some lithium hydroxide. This is the concentration of the lithium hydroxide, so I'm just going to highlight that. That's important. So we're going to start here with the balanced equation between oxalic acid and lithium hydroxide. So back from names and formulas for acids, it ends in ic, so it must be the oxalate ion. Oxalate is here we go, C2O4 with a -2. I'm going to write H2C2O4. Lithium hydroxide is LiOH. They're both +-1. All neutralization reactions make water and a salt, and that salt's going to be lithium oxalate, C2O4. It is not going to be LiC2O4. All right, charges have to balance. So for a lot of you on the acid reactions, you didn't write balanced salt formulas. Okay, same as September, October. Those things don't change. So the easy way is just to do LiC2O4, but sometimes the easy things are wrong. In this case, it's wrong. Li2 C2O4. Also, you have to balance it. Some people didn't balance the reactions on the homework. You have two lithiums here, so you got to put a 2 in front of lithium hydroxide, and then to balance the waters out, you put a 2 in front of the H2O. And there you go. Balance equation between oxalic acid and lithium hydroxide. Second part, molar ratio between the acid and the base. That is your acid, and that is your base. Okay, all your acids begin with the hydrogen, all your bases end with the hydroxide. So your mole ratio here is 1 to 2. It is not 1 to 1 anymore. So this is why I want to do this one together. 1 to 2 ratio. So that means you need twice as much base, at least twice as many base moles to neutralize the acid. That's crucial for this one. All right, so number 3, I got some emails on how do you figure out the base volume used. If you need to draw pictures, please do so. But for most titrations, the unknown solution or the unknown concentration goes in a flask, and the known concentration, in other words, the base in this case, goes in the burette. So the burette, the base is added until it reaches the 5.5 milliliter mark. And when you're done doing the titration, you're at the 26.25 milliliter mark. So you don't add those two, you're going to actually subtract those two. So we're going to do 26.25 minus 5.50. And I'm going to get 20.75 milliliters of LiOH. That's a glass. Okay. Again, the reason you subtract them is because a burette is used just to figure out where you start and where you finish. That is it. So again, obviously it's easier if you were in the lab doing this, but we got to make do. Also here, there's an acid volume amount that's crucial for number 6 down here. Okay, but keep your acids separate from your bases. So some people will actually highlight things or color things in different colors based on whether it's an acid or a base. You could do that. So I'll go up here and just like highlight the hydroxide molarity in blue. This is the hydroxide volume in blue. So you're going to compare, pretty much you're going to use the molarity of the base and the the volume of the base in number 4. Okay, so don't like combine these two, that doesn't do anything. Okay, so pretty much what's going on here is that the acid is neutralized, completely neutralized when this many milliliters of the base are added. So you get that light pink color. This is why all these titration memes, it turns hot pink and Frodo is up here and he's all upset. This is why this meme makes sense. At the end of the titrations go super slow because an extra couple drops ruins the titration. It turns the dark pink because one extra drop can make it not light pink and not neutralized, and all of a sudden you have extra excess base, which is no good. All right, so number 4, how many moles of lithium hydroxide were used to neutralize the acid? Well, you have to do a mole, or not a mole conversion. You have to use the molarity of the base and the volume of the base. Okay, we're going to use the molarity. Equation. X moles over 0.02075 liters. Right? Again, got to use liters, so don't use the milliliters. What we're doing is solving for X here. Please don't divide these, okay? It's just, this is your very simple algebra. You're doing cross multiplication. You've done it for a long time. So you take the molarity, multiply it by your volume, 0.02 0.2075, and you're going to get 0.003237 moles of LiOH. Now, for sig fig's sake, I'm going to leave this in total in as many numbers as possible because I'm looking at the concentration at the way end. So I'm going to use sig figs just for number 6. But for whatever you do here, you know what? E-learning, sig figs, whatever, fine. All right, so that's the moles of base. So for number 5, how many moles of acid were in the flask? Now you might be thinking, okay, all you got to do is do the same thing. Use the molarity of the acid and the volume of the acid, and you're done. So you look up here and you have the volume of acid, but you don't have the molarity, but it has an unknown molarity. So this is where some people get lost, but that's why we need the balanced equation. Your balanced equation gives you the ratio between the acid and the base. So you have to do a very simple mole-to-mole conversion. And you know how many moles of lithium hydroxide you have. I'm going to do 0.0032237 moles of LiOH. And I'm going to set up a conversion between oxalic acid and LiOH. I don't want to write out the formula for oxalic acid. I'm going to do that. And 2 moles of LiOH. I use my balanced equation, right? That's why in the intro here, when I had the, where is it? The reactant 1-to-1 ratio, this is crucial because that's how you get the moles of your unknown solution, or moles of the unknown concentration solution. Okay, so pretty much just divide it by 2. So I'm going to just divide the moles by 2, and I'm going to use all the numbers because I'll do sig figs at the way end. Here we go. Right, 0.01685 moles of oxalic acid. Cool. So number 6, we have moles, we have the volume. We can solve for concentration. So let's finish by doing that. Molarity is 0.0016185 moles over my volume there, put it into liters, so 0.00350 liters. I've got 3 sig figs, it seems like. Most things were in 3. Yeah, 3 molarity, or 3 sig figs in molarity, 3 sig figs in volume. So I'm going to round it to 3. So divide that by 0.00350, and I get 0.462 molar oxalic acid. There we go. Cool. What this means is that the acid is about 3 times as concentrated as the base. There's no way you could figure that out unless you do the actual titration math. Cool. So that's just, again, a walkthrough of all the math you would need to do for a titration problem. So as you reach, for instance, as you look at number 3 on the homework, it doesn't go through all the steps one by one. It's just blah, vomiting some information up, and there it is. Same as number 5 up here and number 6 on the homework. Okay, so those are, again, the more complicated ones. But numbers 1, 2, and 4 go through it more step by step, kind of like this. Okay, that's it. Thanks, guys.